Okay, hello again. So, let us conclude this internship with this presentation. The title of this presentation is Career in Astrophysics. So, what are the career options in astrophysics, whether it is a nuclear astrophysics or theoretical, experimental, all those things. Okay. So, I am going to cover a short note on various opportunities that we can have after undergraduation or post graduation, right. So, before moving to the deep discussion, let us start with the basic, like what is astrophysics. You guys are already well versed with that, like you have this entire internship and also you guys have good experience in this area. So, it is the study of origin and evolution and structure of the universe, right, very clear, and it involves both theoretical modeling and experimental observation. Mainly when we talk about astrophysics, it is mainly astronomical thing, astrophysical observation, experimental observations. But nowadays with the development of GTR and all this uh, machines, computer machines, we can do theoretical stuff, very hardcore theoretical stuff, which can explain the experimental observations. So, it branches into pure research, understanding fundamental physics and applied domains such as space technology, data science and instrumentation. Okay. So, when we talk about pure research, it is mostly theoretical sciences, okay. And when we talk about applied domains, it is like space technology, SpaceX, NASA and all those things. Data science is also emerging in instrumentations. Okay. What are the various fields in astrophysics? So, one is theoretical astrophysics. It is mainly a physics to study cosmology, like what happened at the beginning of the universe, like inflation period and all those things. We try to understand what happened in the astrophysical point of view, what is dark matter, what is dark energy. And if we come back to our business, neutron stars, what are neutron stars, what are they made of, what are their macroscopic properties such as mass and radius. We try to understand this using theoretical astrophysics. And black holes, very fascinating objects, very massive, but we know very little about it, right. We do not know much about beyond the event horizon. So, this is very important part of theoretical astrophysics. And in theoretical astrophysics, we use mathematics, simulations and modeling. Obviously, if you have to model a neutron star, if you have to model a black hole, you have to write some code and you have to make some simulation, like okay, how a neutron star merger work. Let us create a merger in our computer and model it and then see it, right. So, for that you need to use some mathematics, not some mathematics, you need to have use extensive mathematics as well as coding, because you have to design a simulation, and then obviously this whole thing combines as a model. Okay. On the other hand, we have experimental astrophysics, which is building and operating telescopes like detectors, so that we can see the sky, we can see the gravitational bodies roaming around the sky, we can try to understand its macroscopic observables, radius, size, velocity and all those things, constellations and what not, you name, you can add into that list, right. And we can study about satellites. So, we can understand it across the electromagnetic spectrum. Basically, for example, if I want to look at the sun, okay, I can look through X-rays, okay, whichever energy spectrum I am interested in, neutron stars, nicer, I need to see in X-rays, infrared, near infrared. So, whatever information I want to get from that particular body, I choose my electromagnetic spectrum for that. Okay. And you might have seen that nebula picture, Horsehead Nebula. So, it is not that visible light is coming through, it is the final picturization which we are seeing through the computer with all the image software processing, but mainly it is not visible to naked eye. You cannot see it in visible spectrum, you need to put some filters, you need to get the data from infrared or near infrared region or in some different energy spectrum, then you analyze the data and you get something. Similar thing is with the JWVB telescope. Okay. And there is something called applied astrophysics. So applied astrophysics uses data science and machine learning in astronomy, and it is very popular these days. It also includes instrumentation and aerospace applications. Defense as well as satellite industries are also part of this field. So nowadays machine learning and data science in the boom. So everyone wants to use them in their particular regime, whatever they are interested in, for example research in physics, nuclear physics or anything, because it is providing us superpowers to do the task which we were doing in like 1 hour. Now we can do it in 10 minutes. Okay, so it is now helping us to play with large data set, and it is making things possible which were not possible in the past. So for example, for me, machine learning, I have not used machine learning extensively, but if I talk about AI has helped me in development of my codes. So I don't have to put efforts in understanding simpler things like which I already know. I can just use ChatGPT and put it in my code, but whenever I need to build some loop logic or something, I need to think hard, and then I go back and forth with ChatGPT and AI thing, and then I put it in my code when I have the final understanding of what is happening, what I need from that.
So
Anyways,
what is the difference between machine learning and AI that you told I didn't use machine learning?
AI is in broader terms. Like AI, you can say artificial intelligence. Machine learning is a part of that. Artificial intelligence is a big set, and machine learning is a tool which makes this thing happen. For example, a machine learning, from its name itself, it can say, okay, how can machine learn from itself, right? For example, if we talk about large language model, which is a generative AI, and what does large language model does, they are trained on certain data. So we are training the model, we are training them from some data, and what are the algorithms we are using to train that data, which is machine learning, right? And
Simply in like we do data analysis in here, it's same, isn't it, about machine learning?
so far we have not used any extensive machine learning in our system, no. So there are some libraries. If you want to do some extensive data analysis, scikit-learn is a library in Python, we can do that. And scikit-learn gives us power. It has inbuilt function that can do that can optimize your code, that can right now we cannot train our model, right? We are not doing any training. So whenever there is a training involved, we will say it is a machine learning thing, because computer is getting some information from something and it is applying it by itself. Right now we are not doing it. For example, if we talk about linear regression, right, least square fitting, we have a like number of scattered points in a graph, and I want to fit them. What method I will use? I will use least square fitting method, right? And I will develop a code, and I will try to use that mathematical formulation, all that thing, and then I will get a point there, right? I will get a line which is the fitted, right, with the minimum standard deviation. But when we talk about machine learning, the linear regression works in a different way. It also gives the final curve, but it works in a different way. It trains itself from the data, it enhances the weight factor or slope factor accordingly. So it is a dedicated different session, and I am also not an expert, but I am looking forward to learn machine learning in nuclear physics code. For example, right now what we are doing, we are using fsolve to get the solutions of that equations, right? And when we have when we scale our system, it takes a lot of time. But if we have machine learning integrated in our system, fsolve, then it can give us the solutions easily. Like it will take less time, it will improvise the guess, it will learn from the guess itself, and it will provide the best guess that we can achieve the solution pretty soon. Okay. Okay, so let us continue with this presentation. So what are the various astrophysics institute in India where you can get your masters or undergrad? I am not sure about like whether you can do undergrad in some of the institute, you can explore. So the top institute in India is IUCAA Pune, obviously. It has a very good astrophysics. Obviously, it is an astrophysics institute. Very good very good, I would say, research in nuclear astrophysics. Professor Debarati Chatterjee, she is working in the field of nuclear astrophysics. And then we have TIFR Mumbai, very renowned institute. RRI Bangalore, IIA, especially for astrophysics. PRL also for astrophysics. Ares is dedicated for astrophysics. It has an observatory as well. ISRO is for applied space based research, not theoretical pure research. IISc is theoretical. NCRA is more like a telescope experimental thing. So if you want to know more about the career options, you can visit the website of these institutes, okay, and you can search various undergrad and grad program as well as the internship. So I know, like, you guys have also applied for various internship, which is very good. You are using your time, you are using your summer very good. I really appreciate that. And what are the various exams and fellowships that you can get? So you might also know that there is an exam called JEST, and if you get it, if you pass it, you can get admitted in IUCAA, IIR and other institution. So it happens every year, okay. And then there is a GATE exam for IISc and some IITs. If you qualify GATE, you can go study in IISc and some IITs. And then we have CSIR-NET for theoretical research. If you want to pursue PhD, you can apply for this exam. You can appear for CSIR-NET exam, and if you get a JRF, then you have your own money to research and PhD wherever you want, as long as the research supervisor is happy to accept you. And you can also go to do research if you have a GATE and JEST. Obviously, using JEST, you can get admitted to a master's in some institute and eventually PhD. With GATE, you can go to masters as well as masters for engineering and PhD for physics, okay. And CSIR-NET, it is for dedicatively for PhD and theoretical research. Then you have like some specific exams for the institute, like TIFR GS, IUCAA, and CRA exam, which are dedicatively for the particular institute. You can go through that, you can appear for that, and if you crack it, you will get the admission. And at last we have ISRO. ISRO has their different exams. I am not an experimental physicist. I know more about theoretical stuff than experimental stuff. So you can explore more on ISRO websites and all those. What are the various job pathways that you can take in ISRO or like NASA kind of things. What are the opportunities in abroad? Okay, top institution in, if we talk about top institution in USA, then we have Caltech, where Feynman was professor at some time, Princeton, Harvard, and then we have UC Berkeley, MIT, University of Chicago. These are the famous astrophysics institute in USA. And Europe, if we talk about Max Planck, University of Cambridge, Oxford, CNRS France is also very, and European Space Agency or something, ESO, should be O from something, maybe observatory, European Space Observatory. In Asia, we have Kavli Institute in Japan, very famous, National Astronomical Observatory China, and South Africa we have SKA. Okay, so these are the top institutions in abroad which you can check. And for that, okay, I have written the pathways here. So you need to get PhD in physics or astronomy after a master's or directly after BSc in some countries. And if you have a PhD, you can also do a postdoctoral research in observatory or university like I did in some university. And if you are interested in space agency career, then you can look into NASA, European Space Agency, Japan Space Agency, and obviously Indian Space Agency. So how can you get admitted to PhD programs or master's program in abroad? So you can do it using, you have to give some exam, obviously, right? So GRE physics is the exam which is a qualifier to get admitted, to make you eligible for the interviews, right? but these are optional. The GRE physics is optional after COVID, and I think it is still optional at many places. So now is the time before it reopens. So now is the time you should focus into that and get into GRE. And then we have TOEFL or IELTS, which gives you this credit for English proficiency, which is very much required for various places across the world, various universities. And then in addition, if you have a research publications like in undergrad or masters, that makes your profile very strong. If you have a good statement of purpose, like what you want to do, why you want to admit there, and last but not the least, letter of recommendation. Okay, your letter of recommendation weighs a lot in your application. If you have a good letter of recommendation, you met some personality in some conference or something, some big personality, and you spend a good time with them, and if they are willing to write you a recommendation, it will be very helpful for you. Okay, and if you want a recommendation from me, I'm not a big shot. I'm just a starter, but still I just wanted to say this in the internship. If you want a recommendation from me, I would be happy to giving you, but for that I need to show I see the assignment 3. Okay, so
Sir, like that in GRE, TOEFL, IELTS, first we have to see the what university wants, or we can do directly.
no, you have to see what university wants. This is a very obvious thing, and also yeah, that is right. You have to see what university wants. If the GRE is a requirement, then you have to do it. For example, in Kent State, where I was a postdoc, the GRE was a requirement before COVID, but after COVID they relaxed it. Maybe they have reset it, but I am not sure. So you have to check the websites.
So we will get that much sufficient time, or what happens before GRE, TOEFLs?
What do you mean?
Like right now, I have to see in this university I will be applied. Then only we should do, or is there any other process before than that?
Okay, I will answer that in the end. I never did a PhD from abroad, so I don't know the complete process, but I can refer you to something which will be helpful. If you have question about postdoc, I have a dedicated video for that on my YouTube channel, like how to get into
Like
postdoc.
after plus two people do SAT, then only they apply, no? Like that, is there any options? First, I don't think they do TOEFL IELTS. First they do SAT, then they see university.
Okay.
Like that process is there also. I know.
I am not aware for PhD. I will say honestly, I am more into postdoc thing, but I will share a YouTube video. I will share at the end where you might get your answer. Okay, how many slides I have? I just have 2 slides left. So undergraduate graduate preparation skills needed. Obviously, for astrophysical career in astrophysics, whether it is theoretical, let's say theoretical, you need a strong foundation in physics and mathematics. So very obvious, right? And you have to learn programming language. You can start with Python and you can go more deep in C++. You can choose one of it like C++ or Fortran, but Python is must nowadays because the front layer is mainly in Python. But you have also have to develop some core programming language skills like C++. Then you should have exposure to Linux and LaTeX. So that's why I put emphasis on Linux, like command line interface and all those things. Because whenever you go to some research institute, there is always they mainly work in Linux system, so you have to go through all the command line interface and all those things. I'm sorry, I'm getting a call again and again. I have to pick it. I will be back in 1 minute. Anyways, it got disconnected. Where was I? Okay, so I was talking about Linux. Okay, you should have a strong foundation in Linux, basically how to play with terminal. And LaTeX, obviously nobody writes in Word when we talk about real research, right? Everyone prefer LaTeX, and whenever there are scientific equation involved, they prefer LaTeX. So all the documents, all the they prefer LaTeX, and also thesis is also in LaTeX. So, and the other thing is apply for internship. You guys are already in internship and you have applied several. So, you guys are already well aware of this fact. So, the more internship you do, the more things you learn. You don't learn that in your basic or like traditional classroom setup, because you don't have enough time. You have to cover your syllabus and everything. And then if you are interested, like before going to some master's institute, you have to join some research group. So nowadays we don't have to wait for master's course to do research. You have to start research in the undergraduation itself. You can go to some place, talk to people, and you can start working on a minimal problem and get mentored. And then you have to develop a scientific writing as well as communication skill, which will be very important for your showcase of your interview as well as your research proposal or statement of purpose. And obviously in the next week you're gonna demonstrate that your scientific writing and your communication skill when you are good, when you are presenting, right? And then we have writing good statement of purpose, which is also a very good part. You have to learn this skill, writing again and again, getting it peer reviewed, proofread, and all those things, so that you have a perfect statement of purpose, which whenever the university is gonna see that, and you can get hop in easily, right? And then what are the various career opportunities that you can take after you have some degree in astrophysics? One option is professorship. Okay, the last option is professorship. And then we have postdoctoral research. Okay, you can, after PhD, you can go to some institute or research laboratories where you can enhance your research skills. You can work independently on your research problems. And then we have observatories. We have scientist position in observatory where you can also go. Okay, and you can nowadays you can also do freelancing. You can do YouTube channel and all those things. You can share information with people. You get paid from the YouTube for doing that. You can also develop your companies. You can be more creative. Applied field, ISRO, DRDO, data analyst role, space mission planning, and all those things. If you are interested in that, you can do all those things. Companies, if you have skills like data analysis, applied astrophysics, okay, astrobiology, all these things, you can go to some companies which can hire you to do their stuff. But it is mostly applied. It is mostly like engineering side of the things, but not theoretical. If you are theoretical, the option is only academia. And alternative careers, what you can do scientific communication. You can create your YouTube channel, Instagram. You can go visit different places, talk about science. You do public outreach. You can do teaching. You can also make policy. If you are interested in how can I spread science, how can I communicate with different colleges, you can also be a policy maker, right? So you guys can also do that. Yeah. So in addition to that, you asked me about, like, okay, I have a video that I always share. Okay, if you go to YouTube and I go to NIT PSS NITJ, okay, and here, maybe here, yeah, if you go to events here, okay, this is a very good, good morning, very good presentation from Hari Prasad Ravi Kumar, which he did his PhD, not PhD, MSc from NIT Jalandhar, and he applied to several university in US, and he got a PhD position in New Mexico State University in New Mexico, US. So he shared his experience about what were the processes, like where did he apply and all those kind of things, like which I don't know because I never applied for PhD, but it might be helpful for you, right? I am gonna share this in the WhatsApp group, so you guys have that if you are interested in, right? So you guys can go through that, and if you have any question, let me know. Yeah, I think that was all about my presentation for today, my extended presentation. It is, I promised you it will be around 3 hours, and right now it is 12:10. So I will wait for like 1-2 questions, and then we can hang up the session.
Hello, sir.
Yeah, hi Arjun.
I want to ask that, so you are being on neutron star. So what are the key research areas? Suppose I want to do this. So I have to ask what are the areas that they are good that's going on, so that it will be keep on going for 5 to 6 in this astrophysics part.
Okay, yeah, that's a very good question. In terms of research, if someone's asked me what are the promising areas in next 5-6 years in neutron star especially, neutron star physics is pretty old, like it started around 80s or 90s, but nowadays with the advent of LIGO and NICER, it is again booming up, and neutron star equation of state business will remain active for like couple of years due to the LIGO. So LIGO is mainly to measure the gravitational waves, and the gravitational waves are coming when the black holes are colliding or neutron stars are colliding. And the neutron stars colliding, we are interested in the equation of state, and that system is at finite temperature, right, at around 50 MeV whenever the two stars are colliding. Not colliding, I mean whenever they collide. So the system gets around 50 MeV, right? So the finite temperature equation of state is a good business, that I'm saying business, research business. We have to earn something, right? We have to make money, not for like profit, but for our livelihood. So it is a good business with next I would say 10-20 years, because LIGO project is gonna be very far. But the problem is with the new governments like policies, I feel like they are cutting budgets in pure research, right? They are not pushing much budget in the pure scientific research, such as equation of state, or which are not related to applied sciences, right? So that's why, but still it will be due to LIGO and all this stuff. I feel like the merger thing will be there. And also there is a very important update, nobody has announced it. It is like we have to realize it by ourselves, that we have to start using AI extensively in the coding, in any research problem. We have to start using machine learning, we have to start AI, we have to start deep learning in our coding problems, so that we can optimize our code, and the government is gonna push budget to that area, because nobody can resist that. So this is one of the promising thing. I am also thinking to writing some project which involves this AI and ML thing. So this is what I think about this question.
Okay, thank you.
We can go for machine learning also from this project, yes, sir.
This project?
Yeah, like you told, I want to do in machine
Yeah, we can do it. This is one of a significant research problem. It might take 1 year to execute it. I have few papers where the guys have done it, some research person, but I need I have this goal that I want to create a RMF model which doesn't solve the equation using fsolve, but using linear regression or some sort of machine learning algorithm which can give me the fitting, which can give me the solution of mean field like sigma omega. The problem is that like we have a huge constraints. I didn't talk about that. but we don't have much experimental data to fit our model to, right? So when we have huge constraint from the experimental side, we need to put as many equation of state we can put in that system, and we cannot create as many equation of state from the model. We need to use some scalable optimized code, and for that machine learning will help, because it can do fast things fast. Okay, they might not be 100% physical, but we can get it physical using machine learning techniques and using the constraints side by side. Okay, I guess I answered your question. Is there any other question? No. Okay, then let me conclude this session, okay, and my lectures. So I would like to start with thanking all of you. There are not many participants today, maybe 7, so usually we are around 12. Thank you for giving me this opportunity. I enjoyed this very much. I got a lot of things to learn. I learned a lot of things from this internship, and now I am more structured. I have things which are very structured, and I have some more things to think about, like in terms of research. And I hope you guys also liked it, and you have the recordings. You can always visit there, apart from that pandas data frame I missed due to some reason, but I will think about completing it. So we will meet again. If you have like something to discuss on Friday, we will talk. Otherwise we will meet again on the presentation day, and if you have any doubts in the cyber infrastructure running and all those things, you can always reach me out through the WhatsApp. Okay, so so far so good. So we'll meet in few days. Okay, thank you. Bye bye.